All right, guys, so here we are in our next section. This is 14.3 through 14.4, population density, distribution, and growth pattern. So our key concepts, we've got each population has a density, a dispersion, and a reproductive strategy. And then populations grow in predictable patterns. Our vocabulary, we've got population density, population dispersion, immigration, births, emigration, deaths, carrying capacity, population crash, exponential growth, logistic growth, limiting factor, density dependent limiting factors, and density independent limiting factors. Our essential question is just how do populations grow and what types of things can have an effect on them? All right, so here we are. First definition. So population density is the number of individuals that live in a defined area. And population density is a measurement of the number of individuals living within a defined space. And scientists can actually calculate the population density by using an equation. So they just take the number of individuals, however many they count up in a specific area, divide it out, and then they get the population density. Okay, our population dispersion refers to how a population is spread throughout an area. And we have three types of dispersion. We have clumped, and you can see that up there where groups are kind of clumped together in that area. We have uniform, where each individual is uniformly distributed, so they have their own little small territories. And then we have random, where you can just find things randomly here and there throughout the ecosystem, no distinct pattern. And the size of a population is always changing. We have four factors that affect the size of a population. We have immigration, which is the population that moves into an area to join an already existing population. So people moving in or animals moving in, different organisms moving in is immigration. We have births, you know what that is. We have emigration, which is populations moving out of an area to join a population somewhere else. So immigration moving in, emigration moving out. And then we have births and then deaths. Okay, so two opposites, immigration moving in, emigration moving out, births being born, deaths dying. So those are the changes that affect the size of a population. Carrying capacity is the maximum number of individuals of population that the environment can support, because you know that there's resources for everything. So you can think about like the carrying capacity is how many individuals can be supported by that environment. You can think about capacity too, like you get on like a bus. The bus has capacity 45. That's how many people can fit on that bus comfortably, right? We could pack in 90 people, but would there be space for everybody? Would everybody have a seat? No. Same thing with the carrying capacity. The carrying capacity is the maximum number of individuals in a population that the environment can support. Is there enough resources for everything? Enough places to hide? Enough food? Population crash is a dramatic decline in the size of the population over a short period of time. So you can see here rainfall and fish kill events. This actually is showing that as the rain increased, our fish that died off from this kind of rain also increased. Okay, and you can see that as this increased, we had a population crash here, where it's a dramatic decline in the size of the population over a really short period of time. Okay, so our first type of growth, population growth, is based on available resources. Our first type of growth is exponential growth. It's a rapid population increase due to an abundance of resources. And this can happen when a species moves into an area it never was at before, and there's a ton of resources, lots of food for it to eat, lots of habitat, lots of different things. And it has a special graph, and you need to pay attention to this because they will ask you this kind of growth on the OC. This graph is exponential, where it climbs, 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 and again, it's due to an abundance of resources, everything that the animal needs to survive. Now, this can't be sustained for a really, really, really long period of time, right? Things can't just keep doubling and doubling and doubling and doubling and doubling and doubling, because at some point they're going to run out of resources. Okay? So usually what we see is this thing called logistic growth. Logistic growth is due to a population facing limited resources. And what usually happens is we have this slow growth followed by exponential growth where it swiftly goes up. And then it levels off because of the carrying capacity of that ecosystem, and it has hit that point where it has so many resources, like the bus is full. That's all the people that can get on. So that's as much that the environment can support. And we say that that graph has an S shape to it. So you can see it grows slowly, followed by exponential, and then it levels out, S shape. And again, on your EOC, you will be usually asked, is this an example of exponential growth or logistic growth? So be very, very familiar with the graphs, even down to please draw little examples of both those graphs for me in your notes. Ecological factors limit population growth. And a thing called the limiting factor, it's something that keeps the size of a population down. And it can be a lot of different things. So we have these things called density-dependent limiting factors. Density-dependent limiting factors are affected the number of individuals in a given area based on these examples. So we have things like predation. Okay, predator-prey relationships are density dependent, right? How many predators are there to the amount of prey? Competition is another density dependent. If there's not enough worms to go around for the robins to eat, well, some are going to die because they don't have enough food. Parasites, density dependent because it can spread through. Disease, because it can spread through those populations pretty quickly. Okay, so here's a graph. So this graph is showing density dependent limiting factors. It's showing predator-prey relationship. And again, we saw this in the video when we watched Amoeba Sisters with the ecological relationships, where if one goes up, the prey goes up, then closely thereafter, we'll see the predator line go up. And then as those predators kill off more prey, that drops down, so then the predators also drop down. And you can see that here, okay, with our moose population and our wolf population. So as soon as that wolf population hits up real high, after the moose population goes high, the moose population drops down low, and again, the wolf population will drop back down. And then as that moose population goes back up, our populations are going to go back up here with wolves as well. So they kind of go together. Density-independent limiting factors limit the population's growth regardless of the density. Examples are unusual weather, natural disasters like fires, hurricanes, floods, and then human activities like if we take out a whole rainforest, we're going to wipe out all of those organisms that live there. Or even like we want to build a parking lot, we take away all those areas where previous organisms were living, and obviously that's going to affect them. All right, so that is it for population density, distribution, and growth patterns. Please let me know if you have any questions.